answer 4.
All right, so right now we're going to look at example 1. Example 1 is asking us to solve the equation 2 cos 2x minus 3 sine 2x is equal to 2, and we want answers from x is equal to 0 to 360 degrees. So the first thing I'm going to do is I'm going to write 2 cos 2x minus 3 sine 2x in the form r cos 2x plus alpha. So I'm going to write minus 3 sine 2x in the form r cos 2x plus alpha. Let's expand. If we expand, we're going to get r cos 2x cos alpha minus r sine 2x sine alpha. Additionally, r cos alpha, the cos 2x coefficient is equal to 2, and r sine alpha, the sine 2x coefficient, which is 3. If I divide sine by cos, I'm going to get tan. So tan alpha is equal to 3 over 2, and alpha is equal to tan inverse 3 over 2. Alpha is 56.3 degrees. So this is 56.3 degrees. So the next thing I need is I need r. So r squared cos squared 2x, not 2x, alpha, plus r squared sine squared alpha is equal to 2 squared plus 3 squared. R squared cos squared alpha plus sine squared alpha is equal to 4 plus 9. R squared is therefore equal to 13. And so r would be the square root of 13. And so my equation is now r, which is the root of 13, cos 2x plus alpha 56.3 is equal to 2. This is my equation. What I did was to start by expressing 2 cos 2x minus 3 sine 2x in the form r cos 2x plus alpha. Alpha is 56.3 and r is the root of 13. So it means that the cosine of 2x plus 56.3 degrees is equal to 2 over root 13. So all I did there was to divide both sides by the root of 13. Now I can say 2x plus 56.3 degrees is equal to cosine inverse 2 over the root of 13. This is Schiff cos 2 over root 13. The answer here is 56.3 degrees. So this is 56.3 degrees. But, so that is the answer in the first quadrant. Cos is also positive in the, cos is also positive in the fourth quadrant. So the answer in the fourth quadrant would be 360 minus 56.3 degrees. The answer in the fourth quadrant is 303.7 degrees. Now, here's something. It's because of that 2x, I need to go around one more time. Remember, the answers for cos repeat itself in every what? In cycles of what? 360 degrees. So the answer now in the first quadrant between 360 degrees and 720 degrees would be 360 plus 56.3. This is 416.3. And the answer in the fourth quadrant would be 360 plus 303.7, and that becomes 663.7 degrees. You are going to see the importance of what I just did in a minute. Give it a minute. So now I can say that 2x would be equal to 56.3 minus 56.3. It would be 303.7 minus 56.3. It would be 416.3 minus 56.3. It would be 663.7 minus 56.3 degrees. All right. So 2x here would be equal to 0. 303.7 minus 56.3. So that's 247.4, comma, 416.3 minus 56.3 degrees, 360. And the next one is 663.7 minus 56.3. This is 607.4 degrees. Remember, the examiner says he wants answers between 0 and what? 360 degrees. But we're not finished. The last thing I'm going to do is I'm going to divide all my answers by 2 to find out what is the value of x. So x would be 0 over 2, 247.4 degrees over 2, 360 degrees over 2, and 607.4 degrees over 2. So x is equal to 0 degrees. 247.4 divided by 2. That's 123.7 degrees. This is 180. And now 607.4 divided by 2. And this is 303.7 degrees. Please note that all the answers all the answers are between 0 and 360 degrees. All right, so next we're going to look at example 52. Example 52 is asking us to solve the equation 12 sine theta minus 5 cos theta is equal to 4. And it says use two different methods. They want values of theta between 0 and 360 degrees. I'm not going to do both methods, but I would at least discuss a possible different approach to the solution. So I'm going to start by expressing 12 sine theta 5 minus 5 cos theta in the form r sine theta minus alpha. So if I expand r sine theta minus alpha, I'm going to get r sine theta cos alpha minus r cos theta sine alpha. So r cos alpha, which is the sine theta coefficient on the right, is equal to 12. And r sine alpha, which is the cos theta coefficient on the right, is equal to the cos theta coefficient on the left, which is equal to 5. Sine divided by cos is tan, so tan alpha is equal to 5 over 12, and alpha is equal to tan inverse 5 over 12. So alpha is equal to we have tan inverse 5 over 12. This is 22.6 degrees. So now we need r. We know that r squared cos squared alpha plus sine squared alpha is equal to 12 squared plus 5 squared is equal to 144 plus 25 is equal to 169. So r squared is equal to all of that. The opposite of square is square root. R is the square root of 169. R is 13. So with all this information, I can now rewrite my equation as r, which is 13, sine theta minus alpha 22.6 degrees is equal to 4. Dividing both sides by 13, I'm going to get sine theta minus 22.6 is equal to 4 over 13. Theta minus 22.6 is equal to sine inverse 4 over 13. So theta minus 22.6 is equal to shift sine 4 over 13. And we got 17.9 degrees. That's the answer in the first quadrant. Now, sine is also positive in the second quadrant. So the answer in the second quadrant is going to be 180 minus 17.9. The answer in the second quadrant is 162.1 degree. So sine is only positive between 0 and 360. Sine is only positive in two quadrants. So theta is therefore equal to 17.9 plus 22.6, and it is equal to 162.1 plus 22.6. Theta is equal to this is 40.5 degrees and 184.7 degrees. I think those are the only two answers. Now, I told you I would at least discuss this other approach, even though I doubt I'm going to go into the solution of it. We're trying to solve the equation 12 sine theta minus 5 cos theta is equal to 4. So 12 sine theta minus 5 cos theta is equal to 4. If I'm not mistaken, how did they do this? I could be wrong. And then let's say that this is equal to 4 plus 5 cos theta. I think what they did next is that they squared both sides. I think that's what they did. So let's square both sides and see what will happen. This is 144 sine square theta. I just want to see where it's going. This is 16 plus 40 cos theta plus 25 cos square theta. Now, what they could do is make this a quadratic equation with only sine square theta alone. Sorry, with only cos theta alone by converting sine squared to 1 minus cos squared. So this is 144, 1 minus cos squared theta is equal to 16 plus 40 cos theta plus 25 cos squared theta. And all we have to do is solve this quadratic equation. Let me just set it up a little bit more. This is 144 minus 144 cos squared theta is equal to 16 plus 40 cos theta, 25 cos squared theta. Bring over everything on the left to the right. So we're going to have 16 minus 144 plus 40 cos theta plus 25 cos squared theta plus 144 cos squared theta is equal to 0. So this is 169 cos squared theta plus 40 cos theta minus 128 is equal to 0. So we all can see that this is a quadratic equation that we can solve. To solve this, we could use the quadratic formula. So when we use the quadratic formula, we're going to get cos theta is equal to something, and cos theta is equal to something else. because when you solve a quadratic equation, you're going to get two answers. So this is an alternative approach, which I'm not really promoting. The first approach is quite good enough. So this is the solution, all right, to the question, and this is the approach I would take to solving it.